All right, friends, still in 2.3. This is problem number 41, and I have to do 4 different things here. I have to use the leading coefficient test to determine the graph's end behavior. I have to find the x-intercepts and whether or not it crosses the x-axis or just touches the x-axis. I have to find the y-intercept, and I have to determine whether the graph has y-axis symmetry, origin symmetry, or neither. If necessary, find a few additional points and graph the function. Use the maximum number of turning points to check whether it is drawn correctly. So, yeah, this goes back to the time well before graphing calculators and well before graphing apps. All right. So it's an oldie kind of problem. All right. So part A, leading coefficient test. Okay. From the earlier part of this chapter, my leading coefficient is 1. So A is positive. Okay. And this exponent is odd. Okay. What is that called? N is odd. Okay. So from that summary page or summary slide, I know that the end behavior is going to be something like this and like this. Now I drew them far apart just to kind of show that this is what is happening at negative infinity for x, and this is what is happening when x is approaching positive infinity. Okay, so that's the first part. Part B says find the x-intercepts, okay, and whether or not it crosses the x-axis, etc. Find the x-intercepts of this? OMG. I'm going to skip that one for now, all right? I'm going to jump to C and find the y-intercept, okay? And of course, for the y-intercept, I just plug in 0 and then find f of 0, okay? And when I do that, it's going to be at 0. That'll be 0, that's 0, and that's also 0. And the y-intercept is at -2. Okay. And then D, determine whether the graph has y-axis symmetry, origin symmetry, or neither. B, C, D. It's an odd function, so it definitely does not have y-axis symmetry. To test for origin symmetry, we can do something simple like does f of x equal f of -x? And here's how I would write it. F of -x, does it equal f of x? And this is the odd symmetry test. All right, so to do that, I'm going to plug in -x everywhere I have x and see if it comes out the same. Okay, f of x is already written down, so I'm not going to bother with it. Okay, so f of -x is -x cubed plus 2 -x squared minus -x minus 2. And if I simplify this, yes, this equals 1x cubed minus 2x squared. Okay, so it already fails right here. Okay, and this will be plus x minus 2. So because this does not match f of x and this does not match f of x, we have failure, in other words, not odd. Okay, so for D, my answer is no symmetry. And for E, add a few additional points on the graph just to check it out. You can, yeah, we should do a little bit of that since we didn't find the zeros. And I have a feeling they'll be at easy integers anyway. So E. We'll go on to the next page. Double that. I'm just going to go ahead and do a t-table. X, f of x, and do some calculations in my head. I know that at 0, this is -2. I'm going to go ahead -1, -2, 1, and 2, like that. All right. I wish Alexa could help me with this one, but no. -2 cubed is -8. Plus +8 minus -2 minus 2. Oh, that is a 0. Excellent. That makes life easy. -1 cubed is -1 plus 2 minus -1. Ooh, all that is 0. Minus 2 is -2. Wait, is that right? No, I lied. It's 0. Okay. Oh, we have another 0 at -1. And when I plug in +1, I'll get 1 cubed plus 2 minus 1 minus 2. Ah, yes. The third 0, I believe. Yep. And when I plug in 2, I'll get some more interesting number. 8 plus 8 minus 2 minus 2. That's 16 minus 4 is 12. Okay, so finally, oh my god, this is a 7-minute problem already. I'm going to graph this whole thing. I know a bunch of points. There's -2, 0 right there. Here's -1, 0. 0, -2 is here. And +1, 0 there. I know that 212 is way the heck up here. And I know the end behavior is going to go down like this. Okay. So I'm just going to connect a bunch of dots. Okay. I got to go back up there. And I'll max out somewhere and go back down. That is it. And that's how things were graphed in the old days. People, enjoy.